Okay, so this is going to be the third week of the Algebra distance learning packet, so May 18th through the 22nd. And we are continuing with quadratic functions. And again, I'm not going to do all the problems, but I will go through some of the ones that I think might be troublesome. So here we have graphing, and it says you can use a table, line of symmetry, and vertex. So we've done those things on the previous days, and we were able to get enough points to draw our parabola. But for these, it doesn't say which of those you have to do, so whatever works for you. But we should by now be able to find the line of symmetry, and then using that, we can find the vertex, and then also factor it to find the roots or the x-intercepts. You should also be able to identify the y-intercept. So all of that will give us some points without making a table. And then if we need to find a few more points, then we can use a table. So let's do number one. All right, so first of all, just looking at that equation, the y-intercept, all right, so that's the term that's constant, so no x attached to it, so that's 3. So there's a point here. And then if we want to find the line of symmetry, remember that was negative b over 2a. Okay, and that's x equals if we want to call it a line. All right, so negative b, so put the negative, and then b is actually negative 2. That's over 2 times the coefficient of x squared is just 1, so 2 times 1. Okay, so negative outside the parentheses with the negative value inside, that changes it to a positive, so we have 2 over 2 or 1. So x equals 1. So here's our line of symmetry, so then our vertex will be on that line, and to find the point where the vertex is, we know part of it, it's 1 comma something, and this is opening up because the x squared term has a 1 in front of it, so it's positive. So it's going to be somewhere below 3. So it could be 1 comma 1, it could be 1 comma 2, or it could be even a decimal. Okay, so let's take a look. So what we're going to do is substitute that x equals 1 into the original equation and then solve it for y. So y equals x squared minus 2x plus 3. So substituting the 1 in, we have 1 squared minus 2 times 1 plus 3. So y equals 1 minus 2 plus 3. Y equals 2. Okay, so y equals 2. So 1 comma 2. So that's our vertex, 1 comma 2. Okay, since it's symmetrical about that line, the dotted line that we drew, we know there's going to be another point here to go along with the y-intercept. All right, so just looking at this, will it cross the x-axis? Or in other words, can we factor this quadratic? I mean, that's how we would normally find the x-intercept. So let's just try it. Let's see if we can factor this thing. Okay, so we have x. So looking at that third sign right there, so that's a plus. That means whatever we put inside has to be the same, and they both have to be a minus because of this one. Okay, so now we're looking for factors of 3 that will add to 2. So we have 1 times 3 and 3 times 1. And we add those together, we get 4. So that just shows us it cannot be factored. And another way to think of it is the parabola will not pass through the x-axis. So we can see that it's going to curve upwards. And to get more points then, since we don't have the roots, we will need a table. So I would like to see at least 2 more points, or at least 1, and then we could find the other one using the line of symmetry. So we've already done x equals 0, x equals 1, x equals 2. So let's try x equals 3. So I'm going to substitute a 3 in there. So if I have x equals 3, so y equals, so 3 squared minus 2 times 3 plus 3. So y equals 9 minus 6 plus 3. So I'm going to do the positives first, so that's 12 minus 6, so that's 6. Y equals 6. So 3 comma 6 would be another point. So 1, 2, 3, 1, 2, 3, 4, 5, 6. So there's a point here, then there's a point across mirroring it on the other side of that line of symmetry. So there we go. So we can definitely see the parabola forming. All right, so something like that. So that's all we have to do. We're just graphing it. But just do whatever methods that you're good at in order to find at least 5 points to graph this. So the vertex and then 4 others. Okay, so let's try another one at the bottom that they just look a little bit different. They're not equal to 0. So what do we have to do there? Well, first of all, we need to rearrange those equations so that they do equal 0. And the way we would do that is we would add 10. This is for number 4. Add 10 to both sides. Okay, so let me rewrite that. So we have n squared minus 7n plus 10 equals 0, because negative 10 plus 10 is 0. So that's our 0. Okay, and the y-intercept looks like it's going to be 10. And we don't have enough squares, so I'm going to count by 2s. So 2, 4, 6, 8, 10. Okay, I'm just counting by 2s. And then anything else? Okay, we could try to factor it. So just in our heads, let's think, okay, factors of 10, it's a positive, so we're going to add to make 7. So 10 times 1, 2 times 5, okay, well, we can factor it. So we have n and n, and then this sign tells us they're both the same, and then this sign tells us what sign that is, so that they're both subtraction. And then we said 5 times 2. So let's think about this. So negative 5 times negative 2, that's going to give us our positive 10. Then we have negative 5n, and negative 2n will give us our negative 7n. So now we split this up, and we solve it. So we have n minus 5 equals 0. I'll just show that step. N minus 5 equals 0, so n equals 5. N minus 2 equals 0, so n equals 2. So we know that at 2, we're counting by 2, so let's make sure we're consistent. So this is a 2, and then 4 and 6, so then the 5 is here. All right, and halfway between those 2 points is going to be our line of symmetry, and also where we're going to find our vertex. So let's see if we can figure that out, and then we can find out where the matching point for this 10 goes over here somewhere. We don't know exactly, so let's wait on that. Okay, so negative b over 2a. So we have negative b, so that's negative of a negative, so it's 7 over 2. So 7 halves, which is 3.5. So at 3.5, so here's 2, 4, 3.5 is like there. Okay, so there's our line of symmetry at 3.5. So then the 10 up here, so that's 3.5 away from that line of symmetry. So we go 3.5 in the other direction, so it's basically at 7, which is here. So there's another point. All right, so we have 4, and now we just need the other half of our vertex. So it's going to be 3.5 comma something. 3.5 comma something. So we need to substitute that 7 over 2 into the original equation to get our y value. Okay, so we have 7 over 2 squared minus 7 times 7 over 2. Not much room. Plus 10. Okay, so we're going to need some common denominators here. So we have 49 over 4. Then I'm going to multiply this. I want to get negative 49 over 2, but I need it over 4. So so 49 times 2, okay, so 98 over 4. So do we understand? So originally this gave us negative 49 over 2 when we multiplied this second term here. Negative 49 over 2. And then we want it over 4, so we just take both of those and multiply them by 2, so we get negative 98 over 4. And then we want the 10 to be over 4, so that's plus 40 over 4. Okay, so now we have common denominator. We can combine everything. So we have 49 minus 98 plus 40. That will give us negative 9 over 4. Or if we want to think of it as a decimal to help us graph it a little bit easier, that is negative 2.25. So on our graph, since we counted by 2's, finding a quarter is going to be tough. But approximately, it will be about there. Okay, so it's on the line of symmetry, and then at negative just over 2. So our parabola will look something like that. And again, all of these we did without using a table. Now a table will just help us to stay organized. So we could do that. And for some of us, it definitely makes it easier to visualize everything and see what's going on. So definitely use a table if you need to. All right, so let's continue. Another word puzzle. I don't know if you are understanding these, but I'll just give you an example. So, I don't know. This one, the second one here, kind of jumped out at me. So if I look at each of those words, it's just an M and then C, right? But what if I put this? Okay, so 3 mice. All right, well, we know the phrase or the story, 3 blind mice. Okay, now why blind? Because they're missing their eyes, right? So this is the word mice without the eyes. So if you have no eyes, you're blind. Okay, so 3 blind mice. And then again, these are kind of like, old storybooks or colloquialisms, things like that. So if you didn't grow up around this stuff, it's probably not going to make any sense. So, just do the best you can. There's another one that we should all know, and that's the bottom left, and it's just think before you act, right? So the word think is literally written before, and then you act, right? Think before you act. Think before you act. All right, anyway, so just have fun with those. Again, it's not really math related, but it is a nice brain break. Okay, so continuing with quadratics and now the vertex form. So if it's written like this, then we don't have to do anything to find the vertex. It's already in that equation. We just look at the equation, we identify it, and that's it. So it's much easier than doing the negative b over 2a and then substituting that back in. I mean, you could still do that, but if it's written in vertex form, we don't need to. So there's an example there, and again, this is all review. We've done this before. So the thing to remember, though, is in this form, we want h and we want k. But you see that the standard form, there's a minus in front of the h. So whatever it is in the equation, we have to change the sign. So looking at our question number 1, that's a negative 7. So the h part will only be the 7. And the k, that's everything. So that'd be negative 4. So our vertex is at 7, comma, negative 4. Okay, and then think about what we just did. We found the line of symmetry first, and then we found the vertex. So the line of symmetry was just the x part of the vertex. So for this one, the line of symmetry is x equals 7. Okay, so again, we should be able to visualize what this is going to look like. So at x equals 7, right, we have a line of symmetry. And then at 7, comma, negative 4, there's our vertex, okay? And then the last part is, does it open up or does it open down? All right, so the number in front of the parentheses, the sign of that number tells us, does it open up or does it open down? The same thing, it's just a that we had in the standard form. it also tells us does it open up or open down. So this is a positive 2, so it's going to go up. Okay, and the bigger the number, the steeper or the more tightly squished together the parabola is. But it doesn't really matter. I mean, you're not graphing these anyway, but you just need to be able to kind of visualize what this is looking like. So it does cross the x-axis, right? So we could factor it and figure out those values. Okay, so that's it. Same thing with the others. Number 2, that's just a 1 in front. Okay. Number 3, this time we have a +1. Okay, so the h, remember, it's the opposite sign, so it's going to be -1 and then -7. So -1, comma, -7, and then I'll let you do the rest. Okay, so moving on. Now we need to graph each of these. And I guess we're going to do it on the same graph. So it says use a different color for each. All right, well, let's do, and these are exactly the same as the previous, so you don't have to redo it. So what was that? Number 1 was 7, -4. So we kind of graphed that already. Okay, so x equals 7. I'll do this in blue. So x equals 7. There's our line of symmetry. Our vertex is at 7, comma, -4. And what else does it say? Use information to graph the vertex and line of symmetry, and that's it. We don't even have to graph the whole parabola. Okay, so let's label that 7, comma, -4. Okay, I'm going to use a different color. I'm going to use red for the other one that we did, and that was -1, comma, -7. Okay, and actually, just as a little extra, I'm going to show that this is opening up. I'm not going to connect it to any more points because I don't know where those points are, but I'm just going to just show that it is opening up. Okay, so now the red. Let's see. We have the line of symmetry is going to be at x equals -1. So here, -1. Okay, and the vertex is at -1, comma, -7. So right there, -1, comma, -7. And then there's a -6 in front of the parentheses, so that means it's going to open down. Okay, and then number 2, I'll leave that up to you. But we're just going to put on the same graph, so I don't know, maybe choose green for that one. Okay, so just moving along, another page of examples, things that we did. We can see in their example, they drew the line of symmetry. We could find the vertex. They graphed the y-intercept. And there's another point that they gave at 1, comma, -1. So a lot of different things that we can do. And then it says to add the points on the other side of the axis of symmetry, the line of symmetry, because it is symmetrical. So you're just basically counting how far away from the line of symmetry it is, and then mirroring that on the other side. So just more tips for graphing. All right, and then here we are, we're graphing. So let's see if we can do a couple of these. All right, so the first one, so the vertex, okay, vertex form. Vertex is at, remember we have to change the sign of the x, so that's +4, comma, and we keep the y, -1. So 4, comma, -1, so that's right there. And it will open up, so we will have x-intercepts. Okay, so to factor this, we would have to multiply out this whole equation and then rewrite it as standard form. So we would need it like that, and then we can factor it. But I don't really want to do all that work if we're just graphing. So it doesn't say to find the x-intercepts. So let's just use a table and see if we can come up with some values. If we do multiply it out, though, we could find the y-intercept, because this is not the y-intercept anymore. So the only thing we get from the vertex form is the vertex. So let's just substitute some numbers in and see if we can get some more points. Okay, so we have 4 comma negative 1. Maybe try x equals 0. Okay, so x equals 0, that will give us the y-intercept. Let's see what we get. So if we put a 0 there for x, let's just rewrite this to y equals, and then we have 0 minus 4, and that's squared, minus 1. So negative 4 squared is 16, minus 1 is 15. Okay, so 0 comma 50, okay, that's way up there. So it's going to go all the way up. So that's not going to help us. I'm not even going to put that in the table. Okay. Maybe try 2, x equals 2, get a little bit closer to the vertex. So if I do that, I get y equals 2 minus 4, and that's squared minus 1. So 2 minus 4 is negative 2. Negative 2 squared is positive 4 minus 1 is 3. So y equals 3, so that would be 2 comma 3. 2 comma 3. So 2 comma 3. Okay, and then we know since this is the vertex, this is our line of symmetry, which means 1, 2 away. So that means we have another point here. We don't even have to do that. We don't have to calculate it. All right, so I get an idea there. So I still want to go up a little bit more. So let's try x equals 1. 0 is way too high, so maybe 1 will still be on our graph. So let's try that. So I have 1 minus 4 squared minus 1. So we get 1 minus 4 is negative 3, squared is 9, minus 1 is 8. So 1 comma 8. 1 comma 8. There's that. And then the other side of the line of symmetry, we have the other point that goes with it. All right, and then we can see, there we go. And something like that. Remember, at the bottom, it's not a sharp corner. It's a curve, it's rounded, slightly rounded. So please do the best you can to not make that a point. All right, so there's that one. And I think the rest you can do. You know, there's no perfect way. I mean, once we get the vertex, I would probably just go one space away at a time to find some more points, because you see what happened when we try to do 0, we got 15, which didn't help us because it's not on the graph. So start off with the vertex, which was at 4, x equals 4, and then try, you know, x equals 3, x equals 2, x equals 1, and then get those points in and go from there. Extra graph paper if you needed it, and then some more puzzles. Okay, again, just, you know, think them through, and then if you have questions, please let me know. All right, so still continuing with vertex form, but this is a little bit different use of it. So something that we weren't able to cover this year was something called transformations, and they're going to be covered again in geometry, but it's basically instructions on how do we move things on a graph. So it could be a polygon, it could be a line segment, it could be a line, it could be a parabola, it could be anything. As long as it's on a graph, we can move it around the graph. We don't change the size or the orientation of it, but we can just move it around, and that's called a translation. So this is what we're doing here. And the vertex form actually is showing us those instructions, basically. So it's just showing us how is it moving. So to the left, to the right, or up or down, based off of the location of the vertex. So think of it as like you draw this, or you dip a piece of yarn in Elmer's glue, and you lay out your parabola on wax paper, and then it dries, right? It's hardened. So now you have this rigid parabola, and you take a pin and you put it at the vertex, and now you can take that and just move it around the graph wherever you want. And as you do that, the equation for the parabola changes. So we looked at this actually on our Desmos activity for Angry Birds. At the end of the vertex part, you could just move that that graph around, and you just saw that the shape of it didn't change, but the vertex changed, so the equation changed a little bit. Okay, so take a look at the bottom, just showing how the graphs are shifting, how they're moving around based off of the vertex. And then we're going to look at this a little bit closer in this next part. Okay, so we have the base parabola is y equals ax squared. So the most basic parabola is just y equals x squared. And you can graph it on Desmos. It is the black line on this graph. And then it's just saying that a equals 1. So we're going to, we don't even need to write the 1 or the a. It's just a 1 there. So y equals x squared. And then the rest are going to be shifted. So it's the same graph, but it's just being moved around. Okay, the opening, the width of it doesn't change. It's just taking that black parabola and it's stuck to a pin, and then we're moving the pin to different locations. Okay, so we need to match these up. Okay, so the first one, A, it's y equals x minus 2 squared minus 4. So I'm just going to write the vertex for each of these, and I think that's going to help us to identify them. So this would be, 2 comma negative 4. The second one is at 3, remember changing the signs of the x value, so 3 comma 4. And the vertex for this one is negative 3, and there's nothing. So if there's nothing else, then it's 0. Okay, and then the last one is negative 4 comma negative 4. Okay, so this should help us to identify things a little bit easier. All right, so A, 2 comma negative 4. So 2 comma negative 4. So that's got to be this one. So what do we do? So we shifted it to the right and down. So the vertex, we shifted it 2 spaces to the right and then 4 spaces down. So positive 2 for the x and then negative 4 for the y. So that would be graph 4. So y equals x minus 2 squared minus 4. Okay. And then, oh, well, actually, it looks like we need to write how it moves. So this one, the graph 4, shifted 2 spaces to the right, 2 spaces to the right, and 4 spaces down. 4 spaces down. Okay, and it's the same, it's facing the same direction, right? So both facing up. Okay, or opening up. All right, next one. Let's use different color. All right, so vertex is at 3 comma 4. So 3 comma 4. So that's got to be this one, number 3. So this was number 3, and this was number 4. Okay, so number 3, how did that change? So we shifted 3 right and 4 up. Okay, and then the next one, probably should choose the same color as the graph, but that's okay. Negative 3, comma 0. Okay, so that's graph 2. So how did that one change? Lots of things there. So first of all, it shifted 3 spaces to the left because it was negative, to the left. The vertex value, okay, so negative 3 here. Inside the parentheses, it's going to be the opposite. So shifted 3 spaces to the left, and what else? Okay, this one looks different than the others. And what? Flipped over. So, and opens down. So it actually mirrored across the x-axis. So reflected. So this one is a reflection and a translation. So again, things that we didn't learn, but you will see it next year. Okay, so the last one must be graph 1. So let's see. Let's just look at the graph first. 1, 2, 3, 4, -4, -4. Yep, that's it. So that's graph 1. And that one just shifted, let's see, left 4 and down 4. And we're always starting at the black one. So that's from that we're going left 4 and down 4. And that's it. So basically, after some practice, you'd be able to just look at these equations without looking at the graph and then identify what sort of transformation took place. Okay, and then this is the last part, and truly, if you can do all of these and you feel comfortable with them, then you're ready for Algebra 2. I mean, we did some exponential work towards the end, actually very appropriate. Our zombie exercise and how that correlated with the coronavirus breakout. So very interesting there. So that will be included in Algebra 2. So quadratics, very heavy, and then as long as you understand exponential growth and decay, then you should be good. So this is like a little quiz. So a lot of this you should be able to do, so let's just go through each one. So number 1, identify the values of A, B, and C. So remember, this is A, including the sign, that's B, and that's C. How do you know if it opens up or down? Okay, so the value of A, right? So we look at A, is it greater than 0? Okay, so it's opening up. A is less than 0, opening down. Not very good parabolas. So it's like that. Okay. Write an equation to find the axis of symmetry. So remember what that was. X equals negative B over 2A. And if you remember from the quadratic formula, that's that very first part, right? So negative B, then we have all the rest, and we have over 2A. So that's that first half of our answer. So think about what that means. Basically, we find our axis of symmetry, and then we're going to go plus some distance over to find the x-intercept, and then we're going to go minus or back to the left the same distance because it's symmetrical, right? So that's where that comes from, is the negative b over 2a. Okay, and then number 4, circle the parabolas that have minimum values. Okay, so minimum and maximum. So think about the opening up or opening down. Okay, and the minimum and maximum is the y value. So looking at this top parabola, so as you look at all the points that are contained along that curve, okay, think about the y values. So this is like, up here, like y equals 20, right? And it goes down, 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 y equals 1, 2, 3, 4. So y equals 4, then it starts going back up, 5, 6, 7, 8, all the way up. So is there a maximum value for y, or does it keep on going forever? It just keeps on going. Okay, so we have a y equals 1,000. So the minimum, there is a minimum, and that's y equals 4. So when it opens up, we have a minimum, and then when it opens down, then this value here is the biggest number for the y coordinate of any point on this parabola. So that would be the maximum. Okay, so minimum, minimum. And that's the vertex. So the vertex is either the minimum value or the maximum value for that. And again, we would have explored this more in class had we had still been in class. So this minimum maximum, you're going to see a lot more further down the road, especially in calculus. A lot more in calculus. So just for now, understand if it's opening up, we have a minimum value. If it's opening down, we have a maximum value. Okay, and then the next part, simplify. So first one is combining like terms. So we have a x cubed term there and there. we have x squared, then we have just one x term, and then we have two constants or two numbers. So just combine those together and write it out as one polynomial. Part B, we're going to multiply using distributive property twice, okay? And then part C, we have to use distributive property first, so multiply this -1 times each of those, and then combine like terms. And then the final one is just distributive property to multiply that 2x. So I'm going to let's do part C. So I'm going to rewrite, so 4x squared minus 3x. I'm going to write the first set of, the first three terms that are in the parentheses. So there's nothing in front, right? There's nothing in front. So I can just rewrite it without the parentheses. Now the second part, there is something in front, which is a -1. So I'm going to multiply that to each of those terms inside. So I have a -3x and then -10. Now I'm going to combine like terms. So I have 4x squared. How many x terms do we have? We have one here and one here. So there's -3 and -3. So that's -6x. And then we have two numbers. So a +1 and a -10 is -9. And that's it. So that's all we're doing, just simplifying. We're not solving, we're not factoring, just simplifying as much as we can. All right, number 6, find the line of symmetry and vertex. Okay, so line of symmetry, remember, -b/2a. So it's a line, so we need an equation. This is a vertical line, so it's x equals instead of y equals. And then we get b is 3, so -3/2. -3/2. And then we're going to substitute that back into the equation to find our y value for the vertex. The vertex is halfway done. We have -3/2, comma, and that's what we're going to find there. So y equals, I'm not going to do this whole thing. We've done lots of these. Remember, we have to find common denominator after you multiply this out. All right, or if you have a calculator that you can use parentheses and exponents and write this all in there, then you could do that and you would get a number. Again, keep it as a fraction. It's just a little bit easier, especially if the number is repeating. So, find that, and then this will be what goes in for the y coordinate for the vertex. Okay, number 7, factor these polynomials. So looks like a lot of them were just factoring common terms out. So like part A, and those are exactly the same, so you don't need to do it twice. So for part A, I can factor a 4 out and an x. So what do we have left? So 4x times what will give us 8x squared, so 2x, right? So multiply that back in our heads. 4 times 2 is 8. X times x is x squared, and then -1. And that's it. Let's go to one like C. Okay, remember C, this was a special case, so think about that. There's nothing common, right? It's a quadratic, so can we factor something? Can we factor it? So think about this. X squared, that's a perfect square, and 9 is a perfect square. So this is the difference of squares. Okay, so how does that look when we factored it? So we have the square root of each of those, square root, and then a plus and a minus. Okay, so try it, multiply back out. We have x squared minus 3x plus 3x minus 9. So those add to 0, so we get just x squared minus 9. Okay, so difference of squares. The other two we're factoring as normal, and x, so this is a positive, so that means the signs that are inside the parentheses are the same, and they are this sign, which is a plus. So factors of 36, that will add to 12. What do we have? 6 times 6. Okay, yeah, that works. Yeah, that should do it. 6 times 6. So 6 plus 6 is 12. And this one is a case of a perfect square. So we can write it like that to make it even more simplified. All right. Second part. Okay, here's the real number 8. So we are solving this time. Okay, solving meaning we're finding the x-intercepts or the roots. So we could factor it. Right away, I'm looking at b, just like the one we just did. So it's a difference of squares. So we have x plus 5, x minus 5 equals 0. Split those apart. X plus 5 equals 0. X minus 5 equals 0. So we get x equals 5, and x equals negative 5, and x equals positive 5. All right, now some of you might have right away thought, okay, well, why don't we just do this? Why don't we add 25 on both sides? So we get x squared equals 25. Square root of both sides, x equals, remember I have to do the plus or minus 5. Okay, same answers, right? A positive 5 and a negative 5. So the difference of squares, you can do either way. So whatever looks good to you, whatever you first think of. Okay, so I'm going to do one more. Let's try D. So factoring. Okay, so we have x and x. So this sign tells us it's the same, and it's going to be this sign. So it's a minus and a minus. Factors of 49, that will add to 14. That's going to be 7 and a 7. So again, we have a perfect square situation, which means we have repeated roots. So x equals positive 7. And remember, that is going to be one of those where it just touches the x-axis. So we really only have one intercept, or only one place that it touches, not two. Okay, and then the rest should be just normal two different number answers. Okay, the next part, we need to graph these, find the line of symmetry, the vertex, and make a table as needed. Again, this is just practice graphing. Really, we don't need, I shouldn't have to show you, but let's just do one just for fun. So let's do A. All right, so they actually give us the x-intercepts, so that's nice. I'm going to do this one in blue. So let's graph those 2 points. So we have 0 and 4. 1, 2, 3, 4, okay. And the vertex, so what's the vertex? So remember to change the sign of the x. So we have 2, comma, negative 4. 2, comma, negative 4 is there. Okay, it should be right in between, right? This is the line of symmetry. So wherever those x-intercepts are, the line of symmetry is exactly halfway between them. So there's our vertex. We have the x-intercepts, and then we know it's opening up. We can already see that from the graph. So I need at least one more set of points. I want to try out here. So like x equals negative 1. So let's put a negative 1 in there. Negative 1 minus 2 squared minus 4. So that's negative 3 squared, which is 9, minus 4, which is 5. So we have negative 1, comma 5. Negative 1, 1, 2, 3, 4, 5. And then because of our line of symmetry, we could put another point there. And now we have enough points to sketch our parabola. And that's it. Okay, so you can do that with B and C. Maybe use a different color, or if you don't have a different color, that's fine. Just do the best you can. All right, and then number 10. Describe the difference between a linear function, y equals mx plus b, and a quadratic function, ax squared plus bx plus c. So you can put the y on the front of that, y equals that, or equals y. So what are the differences? So just write, whatever comes to mind. How it looks on a graph, okay? Straight line, curved line, okay, things like that. I would also ask for similarities, because there are some similarities. Like this value, okay, they're both the y-intercept. So there's some things that are the same in those two equations. All right, so that's the end of our little review, and then a little logic puzzle to finish it off, and then we will start up with the final week on the 26th.